This is Nivedha Lakshmanan. I am a software developer and I am working in Pro India. So we'll go. So okay, today I'm going to talk about performance tuning in MongoDB. So I wanted it to be little interactive so that it would be even more good to learn. So today's agenda is we'll see why do we need to go for No-Sql, and some architecture is followed in MongoDB and I'll explain that, and we'll see what is partition and how to do partition, because we used to say partition key is the key factor in MongoDB. So how do we do that, we'll see, and we'll see some of the performance tuning techniques and the profiler. So why do we need to go for No-Sql? So who are all familiar with SQL? Okay. No-Sql? Okay. So what is the difference then for SQL and No-Sql? Why do we need to go for No-Sql then? Okay, the same thing because I have showed it already. Okay, in order to avoid linked tables we go for No-Sql. So linked tables in sense, for example, if you have a product and an order table, the product ID will be saved in an order table, right? So that is a link that we give. So if you wanted to get the order details, what you will do is like you will go and fetch product ID and name from the product table. It's unnecessary joins and unjoins you need to do. Whenever you insert data, you have to insert in 2 tables, and when you are getting back you have to fetch from 2 tables, so which is unnecessary. So in order to remove these linked data and unnecessary joins only we will go for No-Sql. The other thing is partition. So if you take SQL database, we partition vertically. So if you wanted to have requests at the same time, what you will do is like you will increase the database, increase the storage level. But whereas if you take No-Sql, it is like you scale horizontally. You select a partition key and the partition, for example, let's take this one. So there will be one master node, the others are horizontally scaled to the master node, and for example we are keeping a city name as your partition key. So this secondary will have, okay, this secondary will have Chennai as the value, the other secondary will have Bangalore as the value, the other one will have Hyderabad, and the same way Delhi. If you get one more city, then you will get one more partition and it will be easy for us to fetch the data. So this is why we say that No-Sql is much more efficient than SQL. Okay? And so we'll get into MongoDB. So before we get into, we need some terminologies that we need to know, right? So the first one is in SQL it is kind of table and we insert rows and columns. But when it comes to MongoDB, it is key value pairs. We save it as a JSON. But in MongoDB, it is a binary JSON format. So we say it as BSON document. And if in SQL it is table, in MongoDB it's collection. And schema-less we say, right, key and value, it can be any data that comes in. It can be dynamically set into the MongoDB. So next thing is the protocol we use and the drivers we use to get data, to query, no, for that we use MongoDB drivers. So these are the basic things. I do not want to get into this. Next is, okay, so partition, I just wanted this to be in detail. So what is a partition? So shard key, what is shard key? Anyone? Why do we need to go for shard key? Is it necessary to have it? Yes. So so we have 2 things in partition. We have 2 things in partition. One is physical partition, so which we don't care of. So this will be internally implemented and managed by the Azure Cosmos DB. We don't have to worry about. But the logical partition is the shard key that you give when you create a collection. So this key should be the key factor when you create a collection. So if you create a partition key and that partition key is a wrong one, you have chosen a wrong one for as a shard key, then your data will be fetched very late and your efficiency will be 0. So when you choose a partition key, you have to be very careful. You have to check whether the partition key is suitable. So how to choose a partition key, we will see in the next slide. Okay. So in this example, if you see, so we have a collection, we have 3 collections, circles, okay. So we have 3 collections here, circles, stars and triangles with all the colors here. So I am choosing partition key as color. So my partition will be blue, green and red, right. So I will have 3 secondary nodes with having blue. So I will have blue in one secondary node, red in another secondary node and green in another secondary node. So these are equally distributed among the nodes, right. This is how you choose a partition key. So if for example, if I have taken if we add some other data to it which is not suitable to this data or something higher to this particular node will not be considered, like which is not good for choosing a partition key. Okay, so logical partition is the one that you choose a shard key. So how to choose a partition key? So first key factor is you have to find a right balance. So if you, for example, we are having a data which has an industry, city name and some more details to it. Okay. So if I have a data which is related to manufacturing, retailing, food industry, so on. Okay. So what I have now is like I am choosing industry as my partition key, and for manufacturing it is like more data is there, for food it is no data, and for retail it has some data to it. Okay. So if this is the case, then this becomes the hot partition and this shouldn't be the thing. Okay. So if you are choosing like this, then this is the wrong way. We should choose, like for example, we have a city name as partition key and we have Chennai data and so on, and it should be equally partitioned. So this is how you have to choose your partition key. The second thing is you have to aim for a single partition query. So for example, we have same industry as our partition key. We have manufacturing, retail and finance. So I wanted to get data where the city name is Toronto. So Toronto will be in manufacturing department, retail department and finance department. Then I have to get all the data from all the partitions, which is unnecessary. Like partitioning itself is like we have to take the data immediately. So this shouldn't be the case. So if you make city name as your partition key, then we can get only from one particular node. So this is the second thing when you are choosing a partition key. So we have seen a logical partition, that is a shard key, and when you are choosing a shard key, we have to have 2 things in our mind. One is finding the right balance, the other one is you have to aim for a single partition query. So okay, now we have chosen the partition key. So for some projects we will have read heavy data, for some projects we will have write heavy data, right. So we have 2 workloads here. So for read heavy data, most thing we will use is the where clause. The main thing is the where clause, right. So for example, if you have a Amazon site, and the Amazon sites we have to list all the products. So in order to list all the products, you have to get the data from the database, and you have to open one product with the product ID. So you will have the where clause. So for the read heavy data, you have to use partition key, whatever that we use it in the where clause. So for example, in this case, it is the product ID which will come as a partition key. Whereas in write heavy data, that for example, we will take an IoT sensor which is there. So the IoT sensor will fetch data for every millisecond, right. So for every millisecond the data will be inserted and we will get a unique ID. So that unique ID will be the partition key for most of the write heavy data. So for read heavy, it is the one that we use it in the where clause. For write, it is the unique ID that is there in the table. Okay, fine. So the other thing that I wanted to tell is we have a replica set in Cosmos DB, as Saranya said before. So we have a replica set all over wherever they have the data centers, we have replicated, so that we can, if the India server has become down, we can fetch it from the other servers, other data centers which is nearby. So replica set is something that we use it for fault tolerance. If you fail over, we will use this replica set, and which in turn provides us the high availability. So for this replica set, I just wanted to tell it in detail. So we will have a master node and multiple secondary nodes. At least 2 secondary nodes will be there in a replica set, but only one master node. So what this master node will do is, will fetch all the requests that comes in, will get all the requests that comes in and stores in a local database called OP log, some log that has. Okay, so this OP log will have all the details that comes in, and later it will update the corresponding secondary nodes that needs to be updated. Okay, so every time will this master node be the master node? No. So how it does is like, to each other they will send heartbeat messages saying that okay, I am listening to you, like that it will say. Okay, so when this master node is not receiving from more than half of the secondary nodes, then this will not be the master node. The other one, for example, this secondary node gets messages, heartbeat messages more than that master node, then this becomes the master node. It is a leader election that does in distributed computing. Same way this replica set will also do. So that's it. And so first thing that we need to think is partition. So performance tuning, you have to look for partition key. The second thing is indexing. Okay, so you have chosen a partition key and you have to make it as an index as well, right? So we have multiple indexes, but I have listed some which I have used. So unique index is the one that we create, the object ID, the underscore ID is the unique ID. If you want, you can create another one also. It is same as the primary key in SQL. And the compound index, if you wanted to have 2 key or 3 keys together, then we will have it as a compound index. And multi-key index, and if you have an array, for example your JSON data has some array to it, then we will use this multi-key index to get fetch data easily from an array. And wildcard index, for example, I'll show that. So for example, if you have a data which is nested in, for example document dot data dot and some information I have to get in. So if I wanted to get document dot data dot submit is equal to true, how will I get? That is not possible. For submit I have to put, for image I have to create an index. That is not possible because that is a dynamic data that comes in. I can't go and update every time the index, right? It can be anything. So if you wanted to be this submit as your index, then what we will do is like we will create the wildcard index. So if you wanted that nested data to be an index, that key to be an index, then we will go for wildcard index. The other one is the text index. So basically if you have a description saying some value to it, and that will be your index. So that is not big. Okay, so now we will create an index in Cosmos DB. It is clear till now, right? Should I create the Cosmos DB from the first? Okay. So I have created a Cosmos DB already, and what I will do is like first I need to set the partition key, right? Shard key. So when you are creating a collection, So when you are creating a collection, you will get shard there. So mostly we don't set any shard key, it will be underscore ID. So which is not a good practice, okay. Every time you create a, because we used to create these collection through our code, not through this, right. So we have to set this shard key at first when you are creating a collection. If you have already created your collection, you can't update your shard key, it will be underscore ID for till the end. You have to delete this particular collection and then recreate it with a shard key and then insert all the data. So when you are creating this, you have to give shard key. So I have created one with a shard key and one not with a shard key. So this one with form ID I have created, which is not the best index, which is not the best partition, but still I have made it as a shard key. And the other one without partition is will not have anything, okay. It will say that large shard key has been enabled. So which will be the underscore ID, okay. So this is how you create a shard key, first thing. Second thing is, when you have created the shard key, you have to add indexes to the collection, okay, for the collection that you create. So this is with the wildcard already, so I will just drop it, okay, I will create it again. So I will create index. So for example, I have multiple data to it, I have multiple multiple key to it. So I will just create a child key as unique index. So if this is it has data already, so I can't create, but if it is an unique index, then we cannot store duplicate values, that is the key factor, right. So this is how we create, and we can't do because we have data already. One second. So I will create a new collection saying test. So here I can create some data to it first. So I have created some data to it, and I will add an index name as unique, okay. So these options is for the index that I have told you before, right. But this one ascending is if you use this name as for sorting your data, then you have to choose accordingly. So if the data would be ascending or descending, so based on that it will fetch faster. So I am just clicking as ascending and I am creating a unique index here. Oh, contains data. One second, I will create one more. So I have made a name also as my unique ID. So this cannot be duplicated in the table. And the other one I wanted to show is the wildcard index. So we have only name here, right. So if you wanted it to be an wildcard index, then you will have $** and enter. Okay, that will not be shown in the drop down, but still you have to do it, and you will give one ascending or something, and you do not have to select anything, you can create the index. So this will create a wildcard index, okay. This $* will represent the wildcard index. So if you have a nested data, then it will be easier to fetch. So this is how you create an index for a particular collection. So I have given 2 examples here, and we will go back. Okay. So we have created partition key, shard key and index now. So how do we tune our performance? So base thing we have done and still we are not getting any performance improvement. Then what we will do is we have an explain method that is given by the MongoDB. So this is used as an execution plan as we have it in our SQL database. Okay. So we use this explain and see how much data it takes or how much records that it actually reads and how much record that actually it's been executed as a result. So these information will be given by this explain method, and I will show you like with partition key and without partition key will have at least 1 second of improvement. Okay. So the first method is explain, that will give us the actual read and out, like in and out and the time that is taken. And the second thing is when you are getting the data, the most frequent data can be added in cache, right. So for example, if it is a read heavy application, what we will do is like mostly the data won't be changed, right, mostly it would be the same. So for if you cache those data that is a static content maybe, so if you add that to a cache, then that will improve your performance, because these are the things that we have done in our projects. So many more are there. So there is a book called Performance Tuning in MongoDB which tells us a lot about it. I have that book, I will show you. So caching is the second technique that you can use it to improve performance. In spite you have added the partition key and the index. The third thing is projections. So whatever that what we will do is like we usually select star from and we will put all the data. We will give all the data to the UI, right. So we will get all the data from the API, say where product ID is this, and we will give all the data like product ID, name, everything, right. But the thing that is needed in UI will be only product name, but still we give all the data. So in order to give less data out, we will use projections query. I will tell you like how to do that. So in this example, if you see, I have form responses which has a huge data. If I go and get all the data from it, I have to get 4,70,000 records, 70,000 records. It won't be that easy, right. So what I will do is like I will just project the underscore ID. Project underscore ID. If you wanted to show, then we will say 1. And we have to remove all other to 0. I have lots of data here, so still I will do document. Gives lot of data. Okay, I will do here. So we have aggregations. This will be an stage level. So in this you can see multiple things. Match is kind of find. So match some form ID or child ID equal to null, something we can put child ID equal to null. So this will give us the data. So for example, you have multiple stages for thing you have to find some record and then group by something. So group by maybe with, I have some record here. So I am going to group by with response ID. And maybe value. And I am just going to show the count of it. Okay. So what I have done is I have initially gave a query saying that my child ID should be null. okay, that is a find query. So here my records are with child ID null, okay. So from this record I am going to group by the form response ID and I am just getting the count of each form response ID. Okay, this is the group by statement. If you wanted to add much more to it, you can add the stages. So the MongoDB drivers will support all these stages. C# actually supports methods itself, like that itself will give us group method and you have to pass this as a string to it. We have to pass this as a string to that particular thing, we can fetch data. So this is how you project the data. So now what I am going to do is, so I have told projections, right. So as a result we will get the underscore ID and value out of this group by command, but I do not want this value to be shown. So what I will do is, I will put a projection saying that my value should be 0. Then I will get only the underscore ID. So as we do it in select and column name from the table, then the same way it is projection in No-Sql. Okay, so this projection will improve a little more good. Okay, is it clear? So we have to think of all this partition key, indexing, and we have to see whether the partition key that we have created is correct, and then we have to add some cache if there is a static value to it, and we have to project only the data that is needed, right. And there is one more thing called profiler. I haven't used this, but I have just got to know about it. So profiler is something that we have it in SQL, where we will see what are all the commands that comes into the database. So same way the MongoDB also has a profiler. So we will get all the CRUD operations or the configuration or the administrative command like db.server status. So those all the commands will be sent against the MongoDB instance, and these commands that comes in, these queries that comes in will be traced in profiler. So if you wanted to see which query has taken a long time, you can do that in a profiler database. So this will automatically create a collection in your database that will be system.profile, which will write data that saying that this query has taken a longer time or the time itself. I am not sure what that will do, but this collection will save all the traced information from the queries that comes in. So profiler is by default is off. If you wanted to set that, you can create db.setProfiling level. We have 3 levels here. 0 means it is off, 1 means you wanted to track only long running tasks, then you can go for 1. And if it is 2, then it is the all operation that comes in, CRUD or the administrative commands that comes in. Okay. So I will just show, I have already created two collections here. So one with the partition key, other one with the without partition key. So I've told about the explain method, right. So I've just got one form ID and I have put that as my find method. Is it visible? Okay. So so before this I have to use db.formResponses is my collection and find is the query I am going to match. My form ID should be some GUID I have, and I gave explain. Okay. So what this will do is like this will run and it will say that this has taken, it is in milliseconds, so this will be 3 seconds. So and the data that has read is 56,576 and it has written all the data. So then the partition key that is chosen here is a right one. If this in and out are different, then we have to like error and trial method only we have to use. So we have to make the other one as a partition key and check whether there is some improvement to your data. So this will give all the information. So shard key can be in a range, or the particular key can also be set as a shard key. So those informations will be given in this query metrics, retrieved document count, and size in bytes. So all these informations will be given by this explain method. This will actually help us to improve our performance at least a bit. At least 4 seconds in your data can also be major change, right. So this explain method actually helped us a lot, so that is why. And so this is with partition, so it has taken 3 seconds, right. But without partition I have run the same query, but that has taken 4 seconds, 4.6 seconds. So some change to it, right. So this will this setting partition key will improve your performance a bit. So this is the explain method, and I think that's it. So I have just checked it with 4,76,000 records, and I have chosen one ID and I have got this results. Okay. So this has given some improvement to it. Maybe if you wanted to see the right balance, you can go and check it in Metrics Classic in Azure portal. So in this, if you go into storage, and it will list all the database and the collection that I have chosen, and this will give some. So without partition will not give, with partition will give. It is not showing. Oh. I don't know. This will actually show us this here we will have one more 1 second, last thing. So I will show how it will look like. So there will be one more tab, say with the partition key, and that will show how much values are used as a partition thing. So for example, they have chose some I don't know, they have chosen food products as the partition key. So beef products, vegetable and it's not clear, vegetable and vegetable products, soups, sauces and gravies. So there are 3 data. So in this beef products are little higher. So it is like kind of little more, right. We have to be, it should be in a right balance. So we have to check, we can check this in Metrics Classic in our Cosmos DB. So that's it. Shard key. So those